Good afternoon, everyone, and welcome to the HNRCA Monday Seminar Series. Today we'll have a speaker presentation followed by a moderated question and answer, and you can submit questions in the Q&A box at any time during the talk. Our invited speaker today is Professor Arne Astrup, Senior Vice President at the Novo Nordisk Foundation in Denmark, and previously head of the Department of Nutrition, Exercise, and Sports at the University of Copenhagen. Throughout an internationally recognized academic career, spanning over 30 years, Professor Astrup's main scientific interests have been appetite regulation, treatment of obesity, type 2 diabetes, and cardiovascular disease, and diseases where nutrition and physical activity play a role. Professor Astrup, your research is extremely important for us. Here at the HNRCA, nutrition and obesity is a core area that we study, ranging from the study of biomolecular mechanisms in preclinical experiments to human studies in diet and prevention of disease. So thank you for your time today. It's now my pleasure to welcome our speaker, Dr. Arne Astrup.
Thank you very much for this nice introduction, and it's a great pleasure for me to sit here in Denmark, far away from you and in a slightly different time zone to share some of my thoughts and research with you. To jump straight into it, I think we have all been knowing for many years that one diet does not fit all, but I guess we have had some challenges really to figure out how to determine what diet is best for the individual person living with overweight and obesity if they want to achieve a weight loss. But I think there are some recent findings over the last 10 to 15 years that more and more actually points at that the carbohydrate tolerance or carbohydrate intolerance actually have quite substantial importance for the composition of the diet when it comes to carbohydrates. And I think if we step a little back and look at a typical dietary intervention trial, we have done many trials where we have also, some have of course been with imposed energy restriction, but others have actually just been a kind of ad libitum diet where we wanted to see what happens if we just change the diet to a diet loaded with fiber and whole grain, a little bit like the diets you're also using at your university with the high fiber diet is something that we are a lot inspired in. But we have used diets where you really have a high content of fiber, low glycemic index, a little more protein, etc., and maybe a little bit less emphasis on exactly how much fat and total carbs. And what typically happens is when you move to such a diet, if you are used to have a typical Danish diet, which is not that far away from a typical American diet, you will see there is actually some weight loss. A little of this weight loss is of course due to that you are entered into a trial where the focus is on making dietary change on health, not necessarily on weight loss, but simply on health. But still, it is people who want to lose weight. And you will see there will always be a weight loss also in a control arm. But what is fascinating here is actually the variability in weight changes. So there are actually some people living with overweight who have quite a substantial weight loss, despite the fact that there's no energy restriction imposed. And that, of course, is due to the fact that predominantly that there's more satiety, fullness, and maybe less craving. So they spontaneously reduce their caloric intake and lose weight. But there are also others where you essentially don't see any weight loss or even they gain weight. And this is some of the challenges we have been facing for many years, because we are essentially unable to identify a priori who will be the successful and who will be the failures. And I think we have been struggling really to try to identify biomarkers that can be used the first day when you see the patient and do the screening and etc. to find out what kind of diet is optimal for this particular person with obesity. I think we have moved a little bit in the right direction, but still there's a lot of work to do. So it's not to say that we have lost this or we have solved this problem. But you know, if we go again 20 years or 25 years back in time, I did together with Jim Hill and some of my colleagues way back, we did a kind of meta-analysis to see if people are put on a low fat diet with a lot of carbohydrates, what will happen? And you know, in these days, we had the idea if we just cut down on fat and eat some more carbohydrates, you will actually lose weight and you'll be very successful. And we all know today that this is definitely a truth with some modifications. But if we look at the evidence from these days, it was quite obvious that for these short-term studies, that there was actually a spontaneous reduction in caloric intake when people were randomized to a low-fat, high-carbohydrate diet as compared with usual diet or something like that. And it also produced a slight weight loss of typically a couple of kilos. And there were a couple of meta-analyses showing the same. George Bray also did a quite comprehensive one in AJCN. And so I think that actually supported this recommendation that we should cut down on fat and eat more carbohydrates. Today, we know there are several modifications to that, and maybe the carbs, particularly if it's carbs without fiber and whole grain, that it might actually make things even worse. And also with sugar. So carbohydrates is an entity, a big group of different molecules and foods. So, but you know, later on, we actually did a meta-analysis in type 2 diabetes, people with type 2 diabetes, where we could see that all the randomized trials comparing low fat with low carb diets actually turned out that the low carb was more efficient, both to reduce blood sugar and improve glycemic control, but also slightly to produce a weight loss. So in some way, it's a little fascinating. You're going to have diets that are low in fat that seems to produce weight loss, but you can also have low in carbs. So there's even diets low in protein that seems to be working. But anyway, I think here it's probably a matter of what patient population you are choosing. And I think some of the issues I will move into is that, you know, whether you are tolerant to carbohydrates and they are beneficial for you, or whether you should actually avoid carbohydrates, is a matter of the satiety effect you get from carbohydrates ingestion. And if we look a little bit of the appetite regulation we know today, and we have learned a lot with all the different hormonal systems, we know here in the right panel that we should not forget and that the blood sugar in itself is a quite powerful regulator of appetite. And also, you know, if blood sugar is dropping, you will get very hungry and get cravings for carbs. But as soon as it's coming up, it will take away this hunger and will actually also give some satiety. And amylin and insulin are also some of the hormones that ensure that this is working. And today we know that the glucose uptake into the brain is not only a passive that is insulin independent, it's actually facilitated and stimulated by insulin. And what we also know is that if we are developing insulin resistance, as we are doing with increasing degrees of overweight and obesity, but also if we are developing pre-diabetes or type 2 diabetes, polycystic ovary syndrome or else, that insulin resistance is not only affecting the peripheral tissues as skeletal muscle, but also the brain. And it means that we are typically looking at the type 2 diabetes patients with their in elevated blood sugars, and then, well, it cannot get into the skeletal muscle tissue, but it cannot either go into the brain. And it means really that the satiety effect is attenuated. And I'll come back to that. So it means that perhaps it is so that whether you would get satiety from carbohydrates is really depending on if it's coming into the tissues, into the skeletal muscle, into the brain, because it needs to be intracellular to convey a satiety message in some way. So this is a little bit about glucose and carbohydrates. If we move down to the gut, we know now today that we have ghrelin, we have GLP-1, PYY, CCK. We have other hormones that are really tightly involved in the control of the food intake in the short term. And we know that the best ligands for GLP-1 and PYY are actually fat and protein. It's not carbohydrate, it's fat and protein, and the same for PYY. And then, of course, in the left panel, we have leptin and other signals that are more the long-acting ones that are not really regulating the food intake over a few hours. So it means that perhaps we have a kind of dissociation here that blood sugar and insulin is really powerful for carbs, whereas for protein and fats, it's more the gut hormones. Of course, this is a little simplistic, and for most normal people, it's working hand in hand. But as soon as you start to be more insulin resistant, the right side is being attenuated and is not that effective working anymore. And just to convince you that there's something about this, this is a study where 3 different groups of people had measurements of their intracerebral glucose levels done before and during a hyperglycemic clamp. And it means that you can actually today quite easily measure glucose uptake into the brain. And if you see here that the 3 different groups during such a clamp where the plasma glucose concentration was of course raised to a quite high level, but if you compare with the normal weight subjects who were really insulin sensitive and compared with the people with obesity, they have a slightly decreased uptake by 27%, whereas the people with type 2 diabetes, they actually had a 50% reduction in glucose uptake. And today, this is a fact that we really know that there's insulin resistance in the brain. And this is also connected to cognitive decline and other as dementia, etc., that we know is much more frequent among people with type 2 diabetes. So, but it also affects appetite regulation. And you'll see here from the same study that they were actually able to find not an excellent, but on the other hand, a significant correlation between the glucose uptake in the brain and the subjective fullness score. So I think this is something we need to consider more in the future, that appetite regulation is definitely affected by insulin resistance and type 2 diabetes and other insulin resistant states, and it's particularly affecting the satiety effects of carbohydrates. Now, does this have any clinical effect for patients? And when we started to do this, we actually had many trials in the database we have been conducting over the last 30 years. And this one was a randomized short-term trial with some energy restriction, where we compared a high fat with a low fat, high carbohydrate diet in people with obesity who were just enrolled. And we did not really check their glycemic status. So we knew that there were, of course, many obese with normal normal glycemic, there would be some pre-diabetic, and there would also be some diabetic that were not diagnosed when they were enrolled with us in this European multicenter trial. And you can see we published this, it's nearly 20 years ago, and we really didn't think about it. And the result of the trial here, when we published it, was something you would say, well, it's not a big deal if you impose the same degree of energy restriction with the two different diets, you will get the same weight loss. But now we went back and opened the database and looked at their glycemic status at baseline and see, did it matter what kind of baseline status that had in terms of the insulin resistance, as where we used their fasting glucose as a biomarker for that. And yes, it actually did. Here, this slide and graph is slightly different on what you're used to see, because if you go back and see here, the average weight loss was about 7 kilos over 10 weeks. So 7 kilo is the zero line here, you can see. And so what we're displaying here is the difference between the low fat and the low carb diet. And what you can see here is that the patients who had baseline before the treatment started, who were normal glycemic, they actually did slightly better on the low fat, high carbohydrate diet. You can see it's the blue line, slightly better than they did on the high fat diet. Whereas the pre-diabetic, there were no difference between the two diets. They were pretty close to the zero line. But what is really interesting is that the patients with type 2 diabetes, they lost about 2 kilo more on the low carb, high fat diet. So it means that they lost 7 plus these 2 kilos. And, you know, they were instructed and prescribed exactly the same caloric restriction. So it's clearly something about compliance, that they get more satiety and less hunger from this, so they actually stick better to the diet and lose more. So we analyzed a number of old trials and actually published in HNRCA, you can see here some years ago, where we could show more or less the same in 3 different randomized trials. You could say that this is all post hoc analysis, and that's true, but in some way it has a strength that you know, it cannot be biased or confounded by our knowledge about expectations, because at that time we didn't know anything about their glycemic status. We didn't really think about it when we analyzed it, and most scientists have not really done that before. So this is quite interesting, and I think today there are more and more trials done in patients with type 2 diabetes that have demonstrated that a low carb diet or restrictions of carbohydrates is not probably the most effective way to lower blood sugar, but also to produce weight loss. And this is some of the trials we have been conducting at Bispebjerg Hospital in Copenhagen. And it's just to show this is not a ketogenic diet, really. We have simply reduced the carbohydrate from 55 or 60 to down to 30% of energy. So it's not a dramatic reduction in carbohydrates. They're still allowed to have their carbohydrates. And in some of the other trials, we're actually also lowering the glycemic index simply to allow them to eat more carbohydrates. But still, if you look at their blood sugar, their insulin, there's very substantial reductions right away. And this is not a surprise, because it is the carbohydrates that will elevate your blood sugar. But also, if you look at their satiety, they're definitely achieving better satiety on the diets with fewer carbs. And we have done a number of trials. We have also done trials where it's the isocaloric diets where we have compared these 2 different ones. And that was simply to see how much of the metabolic effect on glycemic control and other biomarkers of health, of how much of this is due to the weight loss and how much is due to a weight loss independent effect of the diet. And we actually found that you can see the body weight is here, that we were not extremely successful in maintaining the weight loss. So there was a slight weight loss in both groups and no significant difference between the groups. But no matter of the weight, there was clearly a much better reduction in glycemic control, but also in triglycerides, etc. And the most fascinating was actually that the carbohydrate-reduced diet had a highly significant reduction in fatty liver infiltration measured by MR scan. So it also seems to clear the liver from fatty infiltration, which is probably a very important link to a lot of the metabolic, cardiometabolic effects of diabetes. And I think if you look at the guidelines today, the American European shared guidelines, more and more are actually recognizing that for type 2 diabetes, it's quite okay to reduce carbohydrates or even use ketogenic diets and the Mediterranean diet with less carbs and more fat, etc. So I think it's gaining a recognition that this is probably an important part of it, because type 2 diabetes is a disease of carbohydrate intolerance. So it makes a lot of sense. But I think the real issue is the lack of very good long-term results. And I think it's probably something with behavior and food culture that it's difficult probably to stick to this for many reasons over the long term. So still there's some work to do. Well, now I've focused a lot on type 2 diabetes and compared with normal glycemic, but it also looks like that there is something about the pre-diabetic, and that's not really just about how much carbohydrate and how much fat, but more about the fiber content. And I'll show you some results here. We in 2008. We did a large European multicenter trial where we had families with obesity, both the parents and their children. They were enrolled in a trial where the obese parents, they should start with a meal replacement for 8 weeks, only providing 800 calories, simply to induce a rapid weight loss of about 11 kilos. And subsequently, they were randomized to different diets ad libitum. So these diets, they varied in protein and carbohydrate, and also in carbohydrate types. So we had low versus high glycemic index diets. So we had different arms. And the ad libitum concept was simply to see if they have just lost 11 kilos, where we know the biological power really to regain is quite substantial. So what diet is best to try to provide satiety and keep body weight down? That was really the question. And we provided all the foods free of charge for 6 months to all the participants from our supermarket at the university. And we used the barcodes to control the composition of the diet, not for pricing, because it was, of course, free of charge. So we could actually ensure that what they were putting in the basket was according to the planned diet composition based on this computer program we had. And it is what you put in the basket is actually what you're consuming. At least at that time, where not that many Danes were having takeout, it's also coming up now, so it's easier. But we also use biological markers in blood and urine really to see that they were actually consuming the diets. So this trial was, where we analyzed it and published it way back. After this 11 kilo weight loss, they were randomized to these different diets. And what we found was that if they were randomized to a high carbohydrate, high glycemic index diet, they started to regain weight quite rapidly. Whereas if some of the carbohydrate was replaced by protein, up to maybe 22% calories coming from protein, and at the same time, the glycemic index was lowered. So they were quite successful. So this combination of fewer carbohydrates and more with low glycemic index seems to be very effective actually to keep body weight down, at least for these 6 months after the weight loss, even though that it was ad libitum. So nothing about body weight. They were simply told to try to eat until you feel full and nothing more. So we published that in New England Journal of Medicine in 2010. So we felt it was an important result that that we actually tried to continue to build on at a later stage. Now, we were really interested to see, does it matter what kind of glycemic status that they had here at baseline? Because we never looked at that at the time when we published the data. So now we opened up again the database and see here what happened now. Those who had normal glycemic, who were very insulin sensitive at baseline, they did not really, it didn't really matter that much for them whether they had one or another diet. There was a significant difference. Clearly, they started to regain a little bit, but not that much over 6 months. Whereas those with the pre-diabetic, they definitely had a dramatic effect. So you can imagine if you're pre-diabetic, and I think in the US population, it's nearly 40% of the adult population who actually have pre-diabetes according to NHANES. If the choice is between this diet with a little less carb and more fiber and whole grain, a little more protein, it's quite a dramatic weight change, a difference in weight change over 6 months on ad libitum diet. So I think in some way, I feel that at least for those, the big proportion of the population who have pre-diabetes, that we have discovered here that what kind of environmental dietary factors that seem to be important for trigger weight gain and development into overweight and obesity. Now, these results were, of course, very exciting, but it's just one trial, even though it was a big trial. So we wanted to cross-validate that in another randomized trial, and we actually had another trial where we have tested a Nordic, a Scandinavian version of the Mediterranean diet called the New Nordic Diet, where again a randomized trial. And the New Nordic Diet you have here in the left panel, and here you have them in the right panel, you have the Mediterranean diet. We have most of the signature foods are the same, but we don't grow olive oil or olives here in the Scandinavian region, so we use canola oil or rapeseed oil, and a lot of the berries and fruit and all that is something else. But essentially, they have the same content of dietary fiber and vitamins, minerals, and whole grain a lot. So in some way, it's comparable. So we did a trial really to see if this could be just as healthy as the Mediterranean diet. And here we didn't really focus on macronutrients. We were focused on foods. So the aim was to increase the intake of food substantially, berries. It was even organic, and it should mainly be Nordic food. Vegetables went up dramatically, even root vegetables, cabbage, legumes, potatoes, nuts, whole grain, you can see here, it was really, and so by contrast, we reduced the meat intake and also sugar intake, etc. But so it was really loaded with fiber and whole grain. And here, again, we did the same. We published this trial 10 years ago, where we could show that this New Nordic diet actually, despite the fact that, again, it was ad libitum diet, but it clearly induced a slight weight loss that was about 3.5 kilos more than the control diet. Now we again opened this database and looked for any differences in the responsiveness depending on whether you were normal glycemic or pre-diabetic. We didn't have sufficient number of diabetics to also to see what happened with them. But here, if you look at that, this is the normal glycemic group. They had some benefits in terms of spontaneous weight loss on this diet, but for the pre-diabetic, it was a dramatic effect, again, amounting more than 5 kilo weight loss. So it was exactly the same we found in this Shopus study, as we call it, as we found in the DiOGenes. Simply with the diet, it was characterized in slightly different ways, but again, the the common, the shared feature is really the high fiber and whole grain, and probably many other things from cabbage and fruit and berries and other vegetables. But again, I think this is emphasizing that there's something special about fiber and pre-diabetes. We also looked a little bit more on, because if you just use fasting glucose as a biomarker of the diabetic status, this is fine. But you could actually, if you had also a fasting insulin or some better, more measures, you could actually characterize the patients much better. Because if you have a fasting insulin, you can see that those who have a low fasting insulin, their fasting insulin is tightly correlated with your postprandial insulin if you have a carbohydrate meal. So a low fasting insulin is a kind of biomarker of a low insulin secretion capacity. So they're probably close to move into convert into type 2 diabetes, because they have getting close to have used their capacity to increase insulin. So you can see this group here that were pre-diabetic, but also had a low fasting insulin. They were clearly much better off with a high-fat diet. So we think that this is something that can be used that to characterize them, that there's of course a transition from pre-diabetes into diabetes, and those with the low fasting insulin, they are probably closer to the diabetic status than to the pre-diabetic one. We have analyzed many of these data here, and statistically it's quite interesting. There seems to be a quite linear correlation between the fasting glucose and the weight loss when you put people or put the pre-diabetics on the high fiber diet. And this is actually shown here, where we used particularly this new Nordic diet, but also analyzed other diets, and can see that it seems to be quite a completely general phenomenon, that if you have a high fiber diet and you look at blood glucose and have some variability among the people with obesity that you include, you can actually see that there is this correlation. And I think it has some value, because so this fiber, of course, dietary fiber is good for many things, your digestion and bowel movements, and for also for your overall cardiometabolic health. But if you want to address if fiber is good for weight loss and weight maintenance, it's clear that your predictive power is definitely increased if you also look at their fasting glucose. And you can see this, we have published this paper where you can go in and see some of the way we analyze the data. We also discussed this with George Bray and Frank Sachs and other good friends in the US. And we were interested to get access to the pounds lost data to see if we could find some of the same. And here it's just to display one of the most important one. If we look again in the pre-diabetic subset of the pounds lost, and particularly those with the low fasting insulin, again you can see that the fiber content here is tightly correlated with weight loss. And if you look at those, produce a group with a high fiber intake and a group with low fiber intake, the difference in weight loss is actually almost 6 kilos. I know this is observational data, but again, I think it's emphasizing there's something in it, that the fiber is really important. And I think Sue Roberts had been telling me that for many years, but I really see that this is correct and there's something in it. We also, of course, published these data together with the American colleagues. Now, it means in some way, with the data we have today, I think it actually points at type A is what we call it's the normal glycemic. They're probably, quite well off with cutting slightly down on fat and having all the good carbohydrates and protein. But if you go to the other end, type C, what is the type 2 diabetes, there's no doubt about that. The carbohydrate really needs to be lowered, and protein and particular fat is actually very good for them and gives them satiety, probably through GLP-1 and also PYY. But the intermediate group, those with pre-diabetes, it's really the fiber and the whole grain that seems to be most important. So what is it about these fiber and the pre-diabetes? And I think here we are moving now into the microbiota and try to understand, because the fiber, of course, feeds the microbiota we have. And when we started to analyze for this, we used this enterotype division, where you have either the predominant Prevotella type or the Bacteroides type. And you can actually use that in population where you will see that you can almost split people up into two different populations, because there's very little overlapping between those who are the Prevotella subtype or the Bacteroides. And if we look at this 6 months dietary intervention trial we did with the new Nordic diet, I was surprised to see that their enterotype did not change at all. We fed them with all these with this healthy diet, with all this fiber and whole grain for 6 months, and their microbiota did not change at all. In some way, it's a little scary, because it really looks like it's so difficult to change. Of course, there might be ways to do it, but it was published how it did not change it at all. And here you can see how you can split it up into these two subtypes. But if we look at the weight loss achieved on this new Nordic diet by these two enterotypes, so it was surprising to see those who had the Bacteroides subtype, they did not lose weight at all, whereas the Prevotella, they lost a lot of weight again on this diet. So was this just a spurious finding, or is it something that there was something about? And it was definitely not a spurious finding, because we have replicated that in many trials. And you can see this, just some examples here, where we can see that this, if you use this ratio, Prevotella to Bacteroides ratio at baseline, it actually predicts the success you have with the weight loss, how much weight and fat you will lose over the next 6 to 12 months if you're on a high fiber diet. So I don't have the time really to go through all these different studies here, but I'll just show you here from one of these trials that if you look at the association between dietary fiber intake and weight change among those who have the Prevotella, you will see it's quite a steep inverse relationship here. So the more fiber, the more weight loss, and the difference between low and high intake is quite dramatic. Whereas if you have the Bacteroides subtype, there is an effect, I admit, but it's very small, and the difference between the effects is quite substantial. And that's really what we see in many trials. We also had a trial where we compared simply whole grain diet compared with a refined grain diet that was exactly matched in everything apart from the whole grain versus refined grain. And here we can see again the same. And though among those with the high Prevotella, only the high Prevotella group had some benefit from the whole grain in terms of weight loss. And there was a significant weight loss of a couple of kilos. And again, completely ad libitum diet. The only thing that was controlled was the intake of these grain. So moving to the final part of my talk is about, now we are focused so much about carbohydrates, insulin sensitivity, but also the fiber that goes to the microbiota. And therefore it's a little interesting also to see, does it matter to what extent we are good to digest the carbohydrates right away when we are eating it? And it all starts in the mouth with the amylin. And the interesting thing is that it's genetically determined how much activity you have of your amylase. And it's simply determined by the gene copy number. So you can have everything from 2 up to, I think, 16 copy numbers. And the more copy numbers you have, the more activity you also have. So this is something you can use to see if you're a good carbohydrate digester or starch digester, or if you're a bad one. And again, we try to introduce this in some of the same trials here, where our starting point was this, where the high prevotella, they lost a lot of weight here, but for those it was only the high prevotella only for those who had very low amylase activity. It means you're a lousy digester of starch. And of course, it means that all the starch and the fiber and the whole grain will go down into the large intestine, down to the microbiota, because you're not digesting the starch. And it means that most of it will be undigested and move to the last bubble. And here we could see that there was a huge difference between whether you are good to digest or bad. And here it's a good thing that you're bad digester, because it means that instead of being absorbed, a lot of it will end up with the microbiota, where it will be fermented. So I tried to show it here, that here we have a person with low amylase copy numbers, and here with a high one. And here we simply see the carbohydrates and the fiber coming down. And so to illustrate it, we'll see it's being absorbed here, but much more is for the high digesters. They will absorb most of the starch, whereas the other one, a lot of it would come down and probably also contribute to produce much more short-term fatty acids with probably some satiety effects. So we really see this dramatic difference here. And if you go into you can see what is the physiology of these different bacteria. We actually know that the prevotella, they love this arabinosilans and beta-glucans you have typically from bread kernels, whereas the Bacteroides prefer some slightly different. So in some way we can probably start to see what they digest, what their preferred substrate, and how much they produce of these different short-chain fatty acids. And it actually fit quite well with the arabinosilans that you have a lot of in these bread types with whole grain, that they really love this, the prevotella, and they produce a lot of the propionate. So we have this hypothesis that it could all be linked together in a way where these short-chain fatty acids and probably other mediators will reach the bloodstream, go up to the brain, include and improve glucose uptake by decreasing insulin resistance, but probably also by other means that we completely don't really understand today. So we think this is a very interesting area for personalized and precision medicine in the future, where we can use some of these biomarkers to be much better to tailor-make the diet for the people who want to lose weight. And so this combination of using a phenotype of glucose metabolism, do some microbiota analysis, and also some genetic biomarkers. Here we have actually also only used AMY1 copy numbers. So I think a lot of this is not perhaps ready to clinical translation, but I think the fasting glucose and whether you are pre-diabetic, normal glycemic, or type 2 diabetic, I think is so important that it's something you need to take into consideration for the future. So I think I'm about to stop here, and just finally, we have published a couple of reviews recently, where you can find a compilation of some of the studies we have done, and also many others have made very substantial contributions to this area. And we have, many of our good colleagues have shared studies they have done with us, so we have had the opportunity to reanalyze the data and actually get a lot of good information out of these big, very expensive trials and see if we could squeeze more information out that could have clinical relevance. And as part of this translational effort here, hopefully that's something that could benefit the patients. We also had this paper a couple of years ago in HHN. It's probably a little outdated now, but anyway, it's there. So thank you for your attention.
Thank you so much, Dr. Astrup. That was an excellent presentation. And it's great to have the precision diet concepts raised, since precision nutrition is very much in the front of our minds these days. And then you also kind of ended with it as well. Very nice. Attendees, you can type questions into the Q&A box, or if you prefer, you can use the raise hand feature in Zoom. We will unmute you to ask your question. You can also use the upvote feature in the Q&A box, which will move questions to the top of the list.
Should I take off with some of the first questions?
I can read them to you if that's okay. It's good for the recording.
Okay.
So Larissa Constantino asks, do we need more long-term studies to gain more evidence to recommend low carbohydrate diet for people with type 2 diabetes?
Well, thank you for this question. I was hoping for that. I think, first of all, a low carb diet or reduced carb diet is not a drug. So it means you don't need approval by some regulators to do it. It's just a diet. So I think you can easily try it in your patients because, it's allowed according to the guidelines and you cannot really do harm. So try it. But the second part of the question is, do we need more long-term trials? Yes, I think we need more long-term trials because if we look at the available evidence today, it's really sad to see how few studies that have been done, how few diabetic patients that have been included, and also how short they are. So the evidence base we have is on a couple of hundred of patients. If you look at the drug trials where you have 10,000s of patients on different drugs. So fortunately, I'm sitting in a foundation now and we are funding studies. So I actually have a plan to start to do a Northern European big randomized trials. And I think what we need is probably to do some tricks to increase adherence, the compliance to the diet. And I think we probably need cooking courses and other ways really to change the food culture so you can get used to have fewer carbohydrates, and particularly the high glycemic starchy carbohydrates in your diet, because I think this is a problem for many people. So these low carb diets are extremely effective in the beginning, and so it seems to fade out. And there's no doubt about its lack of compliance. So why do people, or the diabetes patients, why do they not comply when it is so successful for their blood sugar and for their weight? And it's definitely, we don't eat for having a nice blood sugar. We really eat for pleasure and get satiety and all this. So we need to find ways where we can enhance the compliance. And I think it's something about the food culture and palatability and little gastronomy.
Great. I'm going to read this comment from Sue Roberts. It's not a question, but she says, this is great progress, a real pathway to personalization in weight control.
Thank you.
Greg Dolnikowski asks, how many grams of fiber per day do you feed on a high fiber diet?
Yeah, that's a good question. I think, when we start to move up above 25 to 30, we definitely see a nice effect. But even going far beyond 30 grams, you really see some effects. So it's also depending on, on your body size. So in some way it should be normalized. But so far, what I see, the more the better. But of course, it should not be. It should still be consistent with a balanced diet in some way. So I think it's if you have a lot of fruit, vegetables, but also stick to the whole grain bread. We got in Scandinavia, we got a lot of our fiber from rye bread. because this is a whole grain rye bread, which is so there are different ways, and I think it's just to get used to it. You can also have pizzas and pasta made of whole grain, so rice again.
Shangdong Wang says, it's interesting in your study that there were different responses to low carbohydrate GI diets in normal glycemic, pre-diabetic, and diabetes patients, and the greater baseline fasting glucose predicted progress of weight loss. Is it possible that detailed baseline gut microbiota and metabolic phenotype are good predictions of dietary low carbohydrate GI diets among normal glycemic, pre-diabetic, and diabetes patients?
Yes, I think that's, I would say yes. I think all our results is actually supporting that you can make very good predictions about success and failure. I think that some of the shortcomings is that, for example, if you have the Prevotella enterotype, we can see that you are really successful on this high fiber diet. But if you have the Bacteroides, you seem to be a failure. So we also need to find out what should we then recommend those with the Bacteroides. Should we try to stimulate their Prevotella with some prebiotics, and should we even give them probiotics with Prevotella, or the combination symbiotics to see if we can change it, or is it simply to try to feed some of the bacteria they actually have to see if we could stimulate them to produce some of the more short chain fatty acids or some of that. So we need much more understanding here, and I think it's we still have a long way to go.
Sheldon Rowan asks, what is the clinical potential of using acrobose to help Bacteroides dominant and high amylase copy number lose weight? Are there any safety considerations with acrobose?
I think I wouldn't recommend acrobose. It's not used that, it's licensed for type 2 diabetes, but I don't think it's a good solution. There's a lot of people will get gastric discomfort and other, but there are different foods that actually have different fibers that stimulate the Bacteroides. So I think it should be possible to develop a diet. We need to look at that, also with some supplementation perhaps.
Sai Das asks, what is the best diet to increase the Prevotella population in the gut?
Well, we saw that even feeding people with this diet, New Nordic diet or Mediterranean diet, with a lot of the fibers that the Prevotella love, did not really increase Prevotella. So now we're doing trials where we try to give them simply these arabinosilans in as a dietary supplement to see if that could actually increase the Prevotella population and how much. So we haven't had the results yet, so it's something we will wait to see. It brings a little bit back to the question, how much of this microbiota we have is determined from birth and something we get from our mother, or perhaps that is colonized in the first year or so, and how much is it possible to change when we have grown up and being adult, because I think we don't have that much information about that yet.
Okay, Sai is commenting, great, look forward. She very much agrees with what you said, thank you. Andres Artisan Korat asks, what is the best way to achieve a low carbohydrate diet considering fruit, vegetable, and whole grain intakes? And then he has a follow-up with regards, I guess this is with regards to glycemic control, weight loss, and microbiome composition.
Well, I think the best way to achieve the low carb diet is simply to look for all the starchy carbohydrates and the sugar. So it is really to reduce the starchy carbohydrates and go for a lot of the vegetables, and also, lentils and beans and all this that have a high protein and a high fiber at the same time, and little carbohydrates. So I think that there are many the low glycemic index diet is also something that can be chosen. So personally, I think it's not really sustainable to, even though a ketogenic diet is so effective, fantastic effective in the short term. I think there are some people who can sustain it over a long time, but I think most people they like to have some carbs. So therefore, I'm more in favor of if we want to have something that can be used for all patients, that to have a slightly higher carbohydrate content, and there we would definitely go for reducing the high glycemic index carbohydrates, and that's definitely all the starches, and also a good marker is the fiber and the whole grain.
Great, thank you for that. So that was actually our last question, which is great because we wanted to end on time today. So
Good.
So this will conclude today's seminar. Thank you to our speaker, and thank you to everyone for attending and asking your questions. And we'll see you next time. Bye. Thank you.
Thank you very much. Thank you. Have a nice weekend.